Hello everyone, I'm Sean Garinger, KC0AKY, and I'm going to give you a brief overview of DMR. I know a lot of people have seen other presentations. This is just my quick overview. It's by not any stretch of the imagination complete, but I just wanted to answer a few questions that I've seen come up several times. So what is DMR? DMR is a digital two-way radio standard that's used heavily in commercial LMR. The concept is based on TDMA, time division multiple access. So what this means is that each frequency that's in use by DMR is split into two time slots, and each time slot is independent and can carry on a separate conversation. Let me show you what this looks like. So in this diagram, you can see a couple of different modulation standards. There's FM wideband, there's FM narrowband, there's D-star, and then you see down here DMR. DMR uses the same amount of RF spectrum as narrowband FM, but you can see instead of a solid constant signal the entire time that somebody's transmitting, DMR instead breaks the signal up into two blocks. Because it's digital and can use compression, it can actually transmit faster than you can speak. So when you're speaking, it records a small portion of it, compresses it, and then sends it off. So if this is time slot 1, you'll see it transmits for 30 milliseconds and then doesn't transmit for 30 milliseconds and then starts transmitting again for 30 milliseconds. So that's how you can carry on two conversations at once with DMR, because actually when you're transmitting, you're only transmitting 50% of the time. So DMR radios are programmed with something called a code plug, and a code plug contains all the information needed to reach the DMR system. Now most code plugs are designed as follows. They're split into two things: a zone, which is a collection of channels in memory. Usually a zone covers a specific geographic area or sometimes even just a specific repeater, and channels within the zone, which are a combination of frequency, time slot, and talk group. Just because a channel's in a zone doesn't mean that it's related. You can, when you design your code plug, you can combine them in any way that you want. But most people that maintain code plugs and share them publicly do it as I've explained here, where they split it into a zone that's geographic and then channels within that geography. Most DMR does occur through repeaters, but there is some simplex, or what DMR calls talk around, which is certainly viable as well. So in order to make everything work with the different time slots and everything, conversations need to occur within a specific talk group. You could think of a talk group as a party line on a telephone. So talk groups can be assigned for anything. They could be event-based, they could be citywide, they could be regional, national, or even worldwide in some cases. Talk groups are unique. So there is a volunteer group that assigns talk group numbers for use within the Brandmeister network. So you can't just come up with your own talk group. It's coordinated at the worldwide level to make sure that there's no duplication of talk group numbers. So Brandmeister, which I've already mentioned a few times, is a network of DMR repeaters across the globe. They're interconnected via the World Wide Web. Brandmeister repeaters usually follow a set of local conventions when they're establishing their repeaters, and these conventions consist of things such as which time slot should be used for a specific talk group, which talk groups are static and which are dynamic. And I'm going to go into details on what all those different things mean. So first of all, there's things called static talk groups. Static talk groups are talk groups that a repeater owner has selected to always be transmitted from the local repeater, even if no one's currently using them. This means you can turn on your radio and tune to a static talk group. You don't have to kerchunk it or anything. If there's traffic, your radio will start to receive it automatically. Usually, a repeater owner selects a specific time slot for the most frequently used static talk group to keep this separate from everything else. So for instance, around here in Iowa, most repeaters select talk group 3119, which is Iowa statewide, for time slot 2. So that reserves time slot 1 for all sorts of other uses, which I'm going to explain here. So the other, besides static talk groups, are dynamic talk groups. Now dynamic talk groups are only available when users request them. So that means that on a repeater, a dynamic talk group is not going to be patched through unless someone locally at that repeater is actually using the talk group. So how do you tell the repeater that you want to use a talk group? Well, you tune to the talk group in your code plug and you kerchunk the repeater. That way the repeater knows that there's a radio that's tuned to that talk group and begins patching it through. Talk groups that are dynamic, once they've begun to be patched through, stay active for 15 minutes after the last transmission. So that means that if you're using a dynamic talk group and you're listening, you need to transmit at least once every 15 minutes. Otherwise, the repeater doesn't realize that there's nobody using that talk group, and the talk group will be disconnected from the repeater. But if you're carrying on a conversation, that should not be a problem because you're transmitting at least once every 15 minutes. So that's a tiny bit of background on DMR. What are some benefits of DMR? Well, the genius of the system is that a time slot can carry more than one talk group concurrently, right? So as I've explained, there's two time slots. You could imagine there could be two conversations, and those two conversations could occur at the exact same time. But what if three different people wanted to use three different talk groups on the repeater? Well, that's actually still possible. So two users can use different talk groups on the same time slot. They will not hear each other, but the traffic will be differentiated for their specific talk group. So if user A is on 31190 and user B is on 31191, they're both going to be on time slot 1, but they're not going to hear traffic that's for the other talk group. The talk groups will be independent. Their radios will only unsquelch when there's traffic for their talk group. So as I've mentioned, DMR can allow two conversations at the exact same time if you're on a separate time slot. If you're on the same time slot, what happens if somebody attempts to transmit into a different talk group when the time slot's used is the radio detects this and it actually gives you a network busy error when you try to transmit. So there's no such thing as a doubling on a DMR repeater. The radio actually checks to see if the time slot is open before it transmits, and if it's not, then it gives you a warning tone that says that the network is unavailable. So let's look at a real world example of how this works. Let's draw this out. It might be a little bit easier to visualize. So we're going to have in this example two repeaters. We have one which is over here in Iowa City, and we have a second repeater which is over here in Des Moines. And each of these repeaters, for the sake of argument, are going to have three people connected. So there's three radios in Iowa City, and there's another three radios here in Des Moines. In this example, let's imagine one person in Iowa City. They're tuned to talk group 3119, which is the static talk group on time slot 2, and they begin to transmit. So their transmission goes from their radio to the repeater. Then next, it goes from the repeater to the internet. It goes into the Brandmeister network. This is the Brandmeister network up here. So the transmission goes to the repeater, then goes to the Brandmeister network. Now, any repeater that's in Iowa is going to automatically have talk group 3119 set as a static talk group. So in our example, the Des Moines repeater, which is the other repeater we're watching, the talk group 3119 automatically comes from the Brandmeister network and goes right into the repeater. This would actually be happening for every repeater in Iowa, and that's why it's important that people don't use 3119 for long conversations, because it's tying up time slot 1 on every repeater in the state. So the repeater gets the traffic, and now in our example, let's imagine that there's two radios in Des Moines which are tuned to talk group 3119. So both of those radios are going to begin to get the traffic. And you can see in this example, right? One person in Iowa City is transmitting, it goes through the repeater into Brandmeister, then it comes back out, goes to the repeater, where it then is transmitted into each of the individual radios. Now let's say somebody else wants to have a conversation at the same time. So we've got one other radio here in Des Moines. They're tuned to talk group 31190, which is a dynamic talk group on time slot 1. So it's not going to interfere with our other time slot. It's a separate time slot. So while this conversation is occurring on 3119, this person over here in Des Moines keys up on 31190. Their radio transmits to the local repeater. The repeater then repeats that traffic into the Brandmeister network, which hits the cloud. Now let's imagine that someone here in Iowa City has already chunked their radio on 31190, which will be this person here. They chunked it a few minutes before our example started. So the repeater in Iowa City has already assigned dynamically this talk group. So Brandmeister here in the cloud knows, yes, we have a user in the Iowa City area that's on 31190, so traffic is forwarded through. So automatically this traffic goes to that repeater, and then finally it's forwarded to the actual radio. Again, this is happening in real time. So these people are all talking, right? This person is talking to these people, and at the exact same time, this person is talking to this person. All transparently, nobody knows the other conversations are going on, nobody's interrupted, and nobody can hear each other, but it's happening all at the same time. And you can see how powerful this is, right? Repeater 2 over here doesn't have to be in Des Moines. This could be in London, this could be in Russia, it could be in wherever in the world there's a DMR repeater that's on the Brandmeister network. You could be there, and all the talk groups are available. So you could go anywhere in the world, and you could come back to talk group 3119, and you could carry on a conversation with people in Iowa. So I hope that that kind of gives you a very, very top level, real brief explanation of how DMR works. I'm going to close this by showing two coverage maps. This is the projected coverage of two repeaters that are going to cover eastern Iowa. This is the Iowa City repeater, and you can see that the red area tends to be where the repeater is reachable indoors, and the green area is where it will be reachable outdoors. So you can see that it almost makes it to the town of Cedar Rapids. And the other repeater that will cover the area is the Independence repeater. This is located up by Waterloo. And again, red is indoors, green is outdoors, and you can see the green area just about makes it to Cedar Rapids. If you have any questions, feel free to contact me either on Facebook or by email, Sean@seangaringer.org. Thanks for watching my video, and have a great day.